Video would be for concept 6, which is section 4.6, and this will be part 2 for that, dealing with completing the square. So I'm going to run through this probably a little fast, but feel free to stop, pause, rewind, whatever you need to do to make sure you get these all complete in your notes. Okay, so let's do a couple quickly with completing the square. So if I were to factor these two, I can write on here, I have a 4 on top and a 4 on bottom. So my two factors are 2 and 2. And so this becomes x plus 2 times x plus 2, which I can write as x plus 2 squared. So these are all equivalent. The bottom one, if I were to factor two numbers that I multiply to get 25 that have to be a negative 10, would be negative 5, negative 5. So again, x minus 5 times x minus 5, and I could write that as x minus 5 squared. All right, so this is important. So this idea with completing the square is that we have some squaring going on. All right, so these were the two examples, x squared plus 4x plus 4 and x squared minus 10x plus 25. The ones we just did are examples of what's called perfect square trinomials, meaning I could write each of these. This is equivalent to saying x plus 2 squared. And this one is equivalent to saying x minus 5 squared. Trinomials, that tri simply means 3, so it's a 3-term polynomial. So x squared, negative 10x, 25, those are my 3 terms I have going on. So to solve a perfect square trinomial, we can factor into the square of a binomial. So then the square of a binomial, this is a binomial squared, and then solve using square roots. So this is what we did in part 1 of 4.6, solve using square roots. So let's just do a quick practice one. If I wanted to solve a perfect square trinomial, I have x squared plus 4x plus 4. Well, this is the one that we had in that warm-up, and so we know it's x plus 2 squared equals 25. To solve this, we solve using square roots. So I'm going to square root both sides. That only leaves me with x plus 2 on the left. Square root of 25 is 5, but undoing a squaring, again, brings in that plus minus 5. So we have x plus 2 equals plus minus 5. So it equals a positive 5, and it equals a negative 5. So I can break this up into two separate equations. So x plus 2 equals 5, and x plus 2 equals negative 5. So subtract 2, I end up with x equaling 3. Subtract 2, x equaling negative 7. So my two solutions are negative 7 and a positive 3. All right, that's nice because we started with a perfect square trinomial. We know we could write it as x plus 2 squared and solve from there. But you will not always be given a perfect square trinomial to solve. But we can make any trinomial a perfect square trinomial, so we can work around that. All right, so if the x squared plus bx is not part of a perfect square trinomial, so just those first two terms, we can use the coefficient b to find a constant c so that x squared plus bx plus c is now a perfect square trinomial. All right, so that probably seems confusing to you. It's all right, we're going to work through that. So here's a roadmap to creating a perfect square trinomial that we can work with. So first up, start with that x squared plus bx. If there is a c, we want to move it to the other side with subtraction or addition. So if we had x squared plus bx plus c, we would simply write it as x squared plus bx equals c. All right, x squared plus bx equals c. Don't worry about the sign on c right now. C just represents some constant value. It could be negative, it could be positive. Don't worry about it. We're going to move that c to the other side. Take half of the b value, so b divided by 2. Square that b divided by 2, and then add to both sides of your equation. So this here in blue, b squared divided by 2 squared, is something new that I introduced that was not originally in my equation. So because I introduced it on the left side of the equal sign, I have to put it on the right side of the equal sign too to stay balanced. Think of if I had a scale and I had weights on each side of a scale. If I put 5 pounds on my scale on the left, I have to put 5 pounds on my scale on the right for the scale to remain balanced. Same with the equations. They have to remain balanced. All right, once I've done that, I've created my perfect square trinomial. So let's just look at what value completes our perfect square. So this one is nothing with solving. We're just trying to figure out, okay, x squared minus 10x plus something will create my perfect square trinomial. All right, in order to do this, I could simply take half of my b value. So my b in this case is negative 10. So I'm going to take half of that, so negative 10 divided by 2. When I do that, I end up with a negative 5. Then I want to take negative 5 and square that to get a positive 25. That's what goes up here in to complete my expression, which is a perfect square trinomial. And how I know it's a perfect square trinomial, this was the second one from the warm-up that we started with. This becomes x minus 5 squared. These are equivalent. Okay, x minus 5 squared is the factored form. On the left, x squared minus 10x plus 25, that's in standard form. But that is a perfect square trinomial because I can write it as x minus 5 squared. One thing I want you to notice here, this negative 5 that came from our b divided by 2, not the b divided by 2 squared, just b divided by 2, that made my second piece to my binomial. All right, so this is kind of a shortcut that doing the b divided by 2 is helpful because that's going to be the second part of our binomial. And then also, when I take that and square it, that creates my perfect square trinomial. Now let's look at actually solving equation, solving by completing the square. So here's the roadmap that you want to write down. So first off, write it in the form ax squared plus bx equals c. Kind of a little addendum to the first one. Divide all terms of the equation by the coefficient of x squared if it is not equal to 1. Meaning, say we had 3x squared plus 7x plus 5 equals 0. Well, I want to get it in the form of ax squared plus bx equaling c, where my a is 1. So I'm going to divide all terms by 3. So now it becomes x squared plus 7/3 x plus 5/3 equals 0 divided by 3 is still 0. All right, so for completing the square, I want it to be where it's just an x squared. Complete the square, meaning create a perfect square trinomial by adding the b divided by 2 squared to each side of the equation. Factor the trinomial, find square roots, and solve for x. All right, so we're going to get it until we have that binomial squared equals a number. Then we can do what we were doing in part 1 of 4.6 and solve using square roots. All right, so for example, let's solve this one. X squared plus 14x minus 38. First, let's check if it is a perfect square trinomial already. If it is a perfect square trinomial, then when I do my b value, my b divided by 2, so 14 divided by 2 squared, well, that's 7 squared, which is going to be 49. This 49 had to be in that spot for it to be a perfect square trinomial. It's not, so now we have a little work to do. Okay, so that work, we're going to create our perfect square trinomial. So x squared plus 14x, this 38, I'm going to move to the other side. So in order to get it to the other side, I had to add 38. So it becomes a positive 38. This 49 now goes right here. So this is a perfect square trinomial. We've created a perfect square trinomial. But because I added 49 on the left, I also have to add 49 on the right. Okay, I got to keep things balanced. I add 5 pounds to my scale on the left, I have to add 5 pounds to my scale on the right to keep it balanced. So now as I continue to work through this problem, I have x squared plus 14x plus 49. So this needs to be factored into a binomial squared. And again, that second piece is going to come right here. And it's a positive 7, so it's x plus 7 squared. 38 plus 49 is 87. Now I can solve using square roots. And so if I square root both sides, I'm going to have x plus 7 here on the left is going to be equal to square root of 87. Square root of 87 is not a nice number. It's not a perfect square. And I cannot change this to a product of two numbers where one of them is a perfect square. Remember, our perfect squares are 4, 9, 16, 25, 36, 49, 64. All of those are my perfect squares. None of those are a factor of 87. Also, because I'm undoing this squaring on the x plus 7 squared, do not forget to add in that plus minus piece. So it's x plus 7 plus minus root 87. In order to solve this, I would subtract 7. So x is going to be a negative 7 plus minus root 87. That would be your final answer, and that's in proper mathematical notation. The square roots always go to the right. Okay, just like if we had 5 times x, we would write it as 5x, not x5. Okay, so our number, our coefficient, or just our number first, square roots go on the end, all the way to the right. So my solution to this, negative 7 plus or minus root 87, and this is how I want it. Leave it exact. Don't give me any decimal values. This accounts for both of them, so it intersects twice. Negative 7 plus minus root 87. Take a look at another one. 3x squared minus 12x plus 6 equals 0. So now this is one where my a value is not 1, so I'm going to divide all terms by that 3. So now I have x squared. 12 divided by 3 is 4x. 6 divided by 3 is 2, all equaling 0. So now we can check to see, is this a perfect square? So that perfect square trinomial. If it is, negative 4 divided by 2 squared is negative 4 divided by 2 would be a negative 2 squared. To get 4, this had to be the same as that. Well, they're not equal. So I can rewrite my piece on the left. I'm going to say x squared minus 4x plus 4. I know this is a perfect square trinomial. Move the 2 to the other side, so it becomes negative 2. But I have to add 4 again. Because I added 4 here on the left, I have to add 4 on the right. Those are the ones that are the same. X squared from the left. X squared minus 4x plus 4. I can write that as a perfect square trinomial, which is going to be x minus 2. Again, that negative 2 in here comes right down. Equals 2. In order to solve this, I'm going to do square roots on each side. So I have x minus 2 equals plus or minus square root of 2. So therefore, if I add 2 to each side, I'm going to have x equals 2 plus or minus square root of 2. We can also complete the square to change a quadratic to vertex form. So again, remember, vertex form is a times x minus h squared plus k with a vertex of h comma k. So we want to solve this one, or we want to change this one into vertex form. We can do this by completing the square. So y equals x squared plus 4x. And then we want to see, well, what value creates my perfect square trinomial? So we do our b divided by 2 squared, and so that's 2 squared to get 4. So this would be 4. I'm going to keep my 6 on this side. So minus 6. But because I added on that 4, so I added this 4 right here, and I'm still working on the right side of my equal sign. 2 remain balanced. This plus 4 was never in my problem. To remain balanced, I'm actually going to subtract 4, because positive 4 subtract 4, 4 minus 4 equals 0. So really, I didn't add anything into my problem. I just have 0 going on there. And so my initial x squared plus 4x minus 6 is still the same as what I started with. All right, so let's rewrite this a little bit. So y equals x squared plus 4x plus 4 minus 10. Negative 6 and negative 4 is going to be a minus 10. This is a perfect square trinomial, which I can write as x plus my 2 right here, x plus 2 squared minus 10. Now I am in vertex form. So from this, I can identify my vertex. Standard form was x minus h. And so really this is x minus a negative 2. So the vertex is going to be at negative 2 comma negative 10. Okay, same question. So our vertex was negative 2, negative 10. Y-intercept. So we have two equations going on. We have standard form, and we also have our vertex form, which was x plus 2 squared minus 10. These are the same. This is the same parabola. It's just written in different ways. The y-intercept I actually find from standard form. So my y-intercept is negative 6. All right, what value of k would make the left side a perfect square trinomial? Okay, so we want to make sure that this is a perfect square trinomial. In order to get a perfect square trinomial, we had to have been able to find this 100 from our b over 2 squared. That had to equal 100. Well, in this case, my b is negative k. So I'm going to say negative k over 2 squared equals 100. So now all I have to do is solve for k. And I can solve for this using square roots. So if I square root both sides, I end up with a negative k over 2 equals plus or minus 10. Multiply both sides by 2 to clear my fraction. So I end up with negative k equals now plus minus 20. I could divide by negative 1, divide by negative 1. So what's happening here is I have 20 divided by negative 1, which is negative 20, but I also have negative 20 divided by negative 1, which equals now a positive 20. So I can say k is equal to plus minus 20. K has to be that value. If I put in here a plus or a minus 20, that will be a perfect square trinomial. All right, so your assignment for this lesson, page 237, these problems.